Order.
Booyah. Thank you, sir. Okay, we're recording. All right, cool. Thanks, Justin. Mhm.
All right, so real high level, what AWS is Amazon Web Services. It's Amazon's cloud offering. It's been around for, gosh, I don't know, 15 plus years. Just in the last maybe 5 or 6, it's really taken off. It allows anyone from startup businesses to learning developers like you guys to enterprises to rapidly deploy infrastructure to support their applications. It takes away the legacy, I guess, management aspect of infrastructure, and they handle most of that for you. So it really leans itself well to rapid deployment of your code. So a developer doesn't necessarily have to know the ins and outs of infrastructure architecture and OS management across all different platforms, scaling, clustering, all that. It handles most of that for you. But it does a ton of other things. It's really popular right now. It's the #1 cloud provider in the world. Microsoft and Google and Oracle being second and third and fourth, maybe not in that order. But their market share is huge. Companies like Netflix, they run almost entirely, if not entirely, on AWS. So I work at Axiom. I've been a developer there for just over 10 years now. I started out doing traditional web development, ASP.NET. Quickly moved away from that into more infrastructure backend development, and then recently I say recently, the last few years have been infrastructure architecture, system administration, engineering, that sort of thing, with some development still on the side. So AWS kind of gives you, if you have a rounded skill set like that, AWS is a really fun place to play. So some of the services that they offer, these are all the services here. The basic ones are their virtual machines that you can stand up in the cloud. That's called EC2. They have their cloud storage, which is called S3. They have databases. RDS is the most popular. It runs either MySQL or Oracle or Microsoft SQL Server. They also have their own flavor that's based on MySQL, which is called Aurora. They have a NoSQL database called DynamoDB, Redshift, which is for huge like data mart databases, all sorts of other things. They have their own flavor of Git repository that's hosted on AWS called Code Commit. And so it hooks in just like any Git. You can use any Git client to communicate with it, but it ties in well to all of their other services. And we'll be looking at that in a little bit. Everything else, pretty much anything that you can imagine that you would need to deploy infrastructure for, there's a service for it in AWS. And one place that AWS really shines is their documentation. So if you want to know how to do just about anything in AWS, there's probably a blog post or a forum post or a white paper written about how to do it securely, which is, like Don mentioned, it's one of the huge things. One cool thing about getting started with AWS is you can sign up for a free account. They have a free tier that's good for 12 months. And just about every service has some free tier options. So it doesn't cost you anything. So for example, you can run a 2-core 512 meg RAM virtual machine running Linux for free for a year in your account. And you can use that as a sandbox to do whatever you want. You don't have to dedicate all of those resources to just a single virtual machine either. You could run 2 of them that are that size for 50% of the day and shut them down at night, and you still wouldn't get charged anything. So we're going to jump right into code commit. So I think it was Randall, I don't know if he's on. He shared with me one of his recent projects that he had committed in GitHub. So I cloned that and I made a couple small changes to get it to compile on my side. And then I created a repo in code commit and just posted the code he sent me for the most part up here. And this is a little web app that does, I think it's like a car dealership page. So for the most part, I didn't have to change anything to get it working in AWS. I just had to change a couple things to remove some features that I didn't really feel like replicating in AWS, because it would have been a pretty big time sink. So he his web application talks to a SQL server, or I'm sorry, a MySQL MariaDB backend. So he provided me with the SQL file to get that set up. So this is his code. And then over in the EC2 tab, I've got a couple virtual machines that are out here. So the first one, this ACA demo, is one that I created from scratch. I I pulled the code from GitHub, I built it, deployed it to Tomcat, and then this machine is up and running. So if we go down here to the information about this machine, you have a public IP address and you have a public DNS name that's not friendly, but it's there. So you can access pretty much any resource right off the bat through a public DNS or IP address. If you wanted to hook it into a static IP address, there's a service for that. And if you wanted to tie this to a domain name that you own, for example, you could do that pretty easily as well. So if we hit that DNS entry on port 8080, that'll take you to his little web application that he wrote. So right away, this gets your code off of your local machine and into the cloud, where you could demo it to other people without having to configure your environment. Or if you want to test different configurations, you can do that in a virtual machine in the cloud instead of messing with the config on your local machine and potentially screwing something up. So the way we create an instance, there's a few different ways. Well, actually, there's many different ways. The most straightforward way is to use the web console here. So it's pretty straightforward. When you log in for the first time, it'll walk you through how to do it typically. So you click Launch Instance. These are all your different operating systems that you can choose. Amazon has their own flavor of Linux that's pretty popular. And you can see if it's eligible for the free tier. It'll say free tier eligible here. Their version of Linux is based off CentOS or Red Hat, Fedora. It's all the same. So it's compatible. It uses like Yum as the package manager. You could also do Ubuntu if you wanted, or you could do Windows. Or if you have some custom OS, you can create an image of that, upload it, and deploy that in the cloud. So we'll do just the first one, Amazon Linux 2, 64-bit. They also support ARM. So if you wanted to do development for ARM processors like Raspberry Pi or whatever, you could do that in the cloud as well. And this is where you choose your resources. So the default is this T2 Micro. That's how they do their naming. It's kind of weird, and they change it every now and then. But basically, the T, or the first two letters, are the class, and the second are the size. So this is a 1 CPU, 1 gig of RAM, and it's free tier eligible. So we'll choose that. These are a bunch of settings that, as a beginner, you don't really have to mess with. If you wanted to deploy, 10 of them, you could do that all at once. By default, you have a network that's already pre-configured in your account, so you don't have to change that. This setting, auto-assign public IP, for your use cases, you would want to do that so you could hit it over the internet. None of these you really have to worry about. This one, IAM role, is something that we will talk about in a little while. I'm going to go ahead and choose the one that I've already created. I don't really have to mess with any of this stuff. And we can go to storage. By default, it just comes with an 8 gig SSD attached to it. You can add more storage if you need to, but for a little web app like this, that's plenty. Tags are user-defined key pairs that allow you to filter or query your instances. Say you have 10,000 instances running for your corporation. You can tag each one, dev, test, prod, or different versions of the application, so you know kind of how to keep track of them. So we'll just call this one name, and the value for that would be ACA demo 1. Security groups are how you secure your resources in the cloud. So it's basically a virtual firewall or firewall rule. You tell it what protocol or what type of connection, the protocol, the port, and then your source. So for us, we just want to be able to hit this web server over HTTP. By default, that's port 80, but Tomcat runs on 8080 by default. So we'll do custom, and we'll say port 8080. By default, the source for that is this SATA range here, which is all public IP addresses. So, somebody in China or whatever could hit your web server, which if you're a new developer or you're just experimenting, you don't necessarily want to expose your resources to, botnets that are scanning the web for vulnerabilities or whatever. So you can limit this to your personal IP address if you can find that. You could also do like custom ranges. You can do multiple here. So if you do my IP, it'll just populate your local IP address and put it in. So only if I set it like this, only I will be able to hit this web server. Everybody else will just get a connection timed out. So we'll review and launch. It gives you an overview of everything you configured, and we hit launch. The key pair, so this will pop up every time you create a new virtual machine. This is an SSH key pair that you'll use to connect to the virtual machine if you need to log into it. If you're not familiar, that's the most secure way to get into a Linux virtual machine. By default, there is no password authentication on these machines. So if you want to log into it and do some custom configuration, you have to use an SSH key pair. For us, the only firewall port that I opened is port 8080. I didn't open 22, which is the SSH port. So even if I configure this correctly, I'm not going to be able to get in unless I go back and add port 22. So this is a key pair I've already generated. If you want another one, you can create a new one, and it lets you download it. So we'll launch, and it's pretty quick here. We go back to the instances page, and you can see that this one, the state is pending. So it takes just a few minutes to get up and running, and then we will be able to hit this empty virtual machine on port 8080. But we didn't do any configuration to it. There's no code out there running. There's no web server running. Tomcat's not installed, nothing like that. So if we want to do that manually, we would open up SSH. We would log in with that key pair that we generated or chose, and we would do all that configuration management ourselves. The other alternative, which is a more automated way, or one of the other alternatives, is to use a user data script. So if we go back, launch another instance, go through this stuff real quick. If we go down to this advanced details, there's this user data, and here you can post a bash script that will execute once when the virtual machine is deployed, and that can do all of your configuration for you. So I have, let me find it here. This one that I wrote that will install Git and Maven, and Tomcat and MariaDB. It'll start the services. It'll copy down from S3, which is the cloud storage, some config that I did beforehand. It'll untar it. It'll clone the repo that I created in code commit. It'll configure the MySQL database. It'll build the code, and it'll deploy it to Tomcat. So if I copy and paste that script here and execute it, it'll do all that stuff, and when it's finished, we'll be able to hit that same web application. So we'll do that real quick. Go through all this. Okay, so while that one's spinning up, this other one that I just created is finished. But if we were to go to this DNS name, since Tomcat or Apache, nothing's installed, it would just time out. Once you have a machine running, you can modify some of the details, like the security group. So let's see. if we change the security group, which was just port 8080, to this other one that I have created that opens up SSH and HTTP, we should be able to actually log into this machine. So I'm using PuTTY. I don't know how familiar you guys are with Linux, if you use it pretty regularly. PuTTY is how I connect to Linux machines. There's other tools out there. If you were doing this from Mac or Ubuntu or whatever, you just SSH over the command line and pass it in that key file, which I've already got saved here.
Hey, Justin, before you move
Yes.
on, while you're on that point, the importance of knowing Linux. It's if you're in, maybe if you're in, Microsoft uh, pure environment, maybe it's not as important. But you want to just talk for 30 seconds about how critical uh, command prompt, Linux level knowledge is if you're a web developer.
Yeah, absolutely. I don't have the statistics, but I would wager that most web applications these days run on Linux. There's probably a few that still run on legacy, ASP.NET or C#.NET web applications. And those are typically legacy, and even now Linux supports the .NET framework. So you have folks that are moving legacy Microsoft.NET code over to Linux anyway. The biggest driver for that is the cost. Microsoft Windows costs significantly more than just running Linux. Enterprise-wise, maybe not so much, depending on how many machines you're deploying. Microsoft has pretty decent enterprise licensing, I think, especially when you compare that to like Red Hat Enterprise, which is based again on CentOS or Fedora, but has enterprise support associated with it. So if you are not familiar with Linux and you want a job as a developer, it would behoove you to learn Linux. It's not overly complicated. There's tons of tutorials and stuff out there, but a good way to learn it is to either use it yourself, so install Ubuntu dual boot or whatever, or stand up a VM in AWS or anywhere else, VirtualBox even locally if you wanted, install Linux and just get familiar with the command line.
Yeah, they'll have Apache on their laptops for the project. I'm just wanting to encourage you guys to not forget about that as you're moving forward and learning more stuff. You'll want to learn more SQL and database fundamentals. You'll want to learn more Java syntax, JavaScript, those sorts of things. Just don't forget that you'll be likely operating in a Linux environment, and if you're used to clicking in Windows, it can be kind of a shock to the system. But it's like Justin said, it's not terribly complex. It's just something to remember to stay on top of. Thanks.
Yep. And it's also worth mentioning that if you install Linux, on your local machine, like on your home laptop or whatever, you can install Ubuntu, which has a nice GUI that is pretty reminiscent of Windows. You can do a lot of the same things in the same way, point and click. But in the corporate world or even the startup world, you're going to be running on machines that are headless like this. So the only interaction you're going to have with a Linux machine is an SSH console like this. So here I am logged into the first one that we stood up, and I can become root and do anything that I want to do. But again, this one doesn't have anything that's installed. It's just a bare bones machine with the OS. The second one that we installed is finished here. So if we're lucky, I didn't do anything to this machine other than post that user data script that executed once when it stood up. If we're lucky, I should be able to go to this one, which is the brand new one, port 8080. All right, so we're not so lucky. So let's try to see what went wrong with this one. And these are the joys of live demos, is that they don't always work as anticipated. So let's log into this guy. right, so it looks like my script did not execute for whatever reason. Yeah, not sure why. That's going to be something that I'll track down later. But for now, we can just kind of move on. Take my word for it that if your script works as it should, it would execute when this gets stood up and it would do all that configuration for you. So that's kind of how you would do it. You know, if you're standing up servers onesies and twosies, you could do it through the console like this. The web console is just a wrapper for the AWS API. So anything that you can do here in the web console, you can do through an API call directly. You can do it through their command line tool on Windows or Linux. You can do it through any number of SDK integrations with Java or .NET or Python or whatever. And then you can do it through a third-party tool, which is kind of what we use typically, is called Terraform. And it's kind of its own beast. So if we close out of this. So Terraform is a third-party tool that is cloud agnostic, so you can use it to deploy resources to AWS or Microsoft Azure or Google Cloud or Oracle Cloud, any of them. And the syntax differs a little bit between each, but it can do all of them, which is really helpful for large enterprises that don't want to be dedicated. They don't want to stand up, you know, their billion-dollar web app on just AWS. Because what happens if AWS has some massive failure, which hasn't happened yet, but it could. So they want to spread that out. They want to account for failure and do half of it in Microsoft's cloud and half of it in AWS, for example. Terraform makes that really easy. You can do it in a couple different formats. JSON is one, and then YAML is the other. If you're not familiar, those are just sort of plain text, I guess languages. It's just how you format your code. So this code here, ignoring the green because that's stuff that's commented out. This does the exact same thing that I just did through the console, but it does it in, 60 lines of code, which a lot of it is autocomplete and a lot of it you copy and paste between projects. So what this allows you to do is say, okay, well, I want, we'll take this one, for example. I want a resource, and it's going to be an instance, which is a virtual machine. AMI is Amazon's identifier for the OS. So this particular AMI is that Amazon Linux 2 operating system. The security group, again, that's our firewall rules. This is the ID of the one that I've created previously. T2 micro, the subnet that it goes in, which is by default, it's already there for you. This is the key name that we picked. We want to make sure that it gets a public IP address so that we can hit it. Root block device, this is how much storage is allocated to it. So it's 30. GP2 is just their identifier. That's that SSD storage. This is the profile we defined up here to have access to it. And here's our user data script. Same thing, but hopefully this one will work. And this is our tag, the name that we would define in the console. So what we can do is open up a terminal and run Terraform validate, and that'll make sure that our code is good, and it is, and run Terraform apply. And it'll parse this code, it'll make the necessary API calls behind the scenes. It takes just a few seconds. And if we go back and look at the console while that's running, you can see that it's stopping the existing one that I had out there by that name because I'd run this previously. And once it stops, it's going to recreate it with that same name. So it saved us, 20 clicks or whatever doing it through the console. We wrote some code and then we executed one command line call, and it'll deploy it for us. So where that's useful is if you have a code base. So say we have Randall's code as web application and he makes a change, we can set up a hook so that as soon as he commits it to the Git repository, this script fires and it updates the web server automatically. So his changes are automatically propagated, which isn't a huge deal for one web server, but say, you're Capital One and you want to update your website, you're running that website on, 1,000 web servers. You can do it the same way. You just tell it, in AWS how many you want, basically, and you execute this script and it'll update all of them at once. Or you can do what's called a blue-green deployment or a canary deployment, where you update half of them on the new version of the app and the other half on the old version of the app, and you slowly increase the amount of web servers that are running the new version and decrease the old version until all of them are on the new version. That way, if there is a bug, it doesn't impact all of the customers all at once. You can monitor for errors as you do that deployment, and if there is, you can stop the deployment and roll back or whatever, or do an emergency bug fix. So that is finished. If we go back here, you can see that this one is running and it's initializing, so it's doing that initial configuration. So maybe when this one's finished, we'll be able to connect to it. And that'll take a couple seconds. While that's going, so the script that we have in here, it installs MariaDB, MySQL, and it runs the SQL script that Randall sent me that creates his tables and inserts his rows and all that. So that has his database running on the same virtual machine as his web application, which for testing or development, that's fine. In production, you typically want to separate those so that if your database or your web application is compromised, an attacker can't necessarily get access to your database if it's on the same machine. Or if your database goes down, your web application that serves other purposes doesn't also go down. So AWS has a service, RDS, which is a managed database service. And basically, we're not going to go through and set one up. But you can create a database here, tell it, what flavor you want, tell it what your database name is going to be, the password, how much storage you need, what kind of instance, is there going to be a lot of throughput? If so, you want a larger machine, or if it's a web application like this, you can, pick a teeny tiny one that doesn't cost very much. And what that does is that gives you an endpoint of a database that you can connect to, and you can administer the database, but you don't have to worry about patching the server or doing any other OS configuration like you would in the other scenario where I had to manually install MySQL and I had to manually execute that SQL file. Here, it's what's called serverless or database as a service, where you tell it what you want and it gives you a database endpoint that you can connect to on part 3306, and you can do all the configuration that you want. And it also has redundancy built in, and it's got auto scaling built in. So if your web application grows and on Black Friday you get a massive influx of orders for your your web app, then the database could scale automatically. So you don't have to manually go in there and allocate more resources for it to keep up with demand. And that auto scaling functionality is something that's built into just about every service that Amazon offers. And of course, you pay a premium for that. Cost-wise, it's more expensive to do it serverless because Amazon has to take on some of that management overhead, but it's more convenient for you. So you don't necessarily need a DBA on your team that's dedicated to maintaining that Oracle instance or MySQL instance. You just let Amazon handle that, and you just interact with the database like you normally would. So this one is finished. Let's try this. All right, still not working. So I must have a bug in my script, I guess. It was working earlier on this one, I think.
You guys should take comfort. Even experts with 10 years of experience, even Charles makes mistakes or, has to troubleshoot stuff. Hey,
This is the other one that I ran shortly before I connected. So we'll pretend that this is the one that I just created. But yeah, that's pretty much the gist of it. Assuming that the script execution did what it was supposed to, which clearly it did not, this is what you would end up with. A live production website that if the firewall rules allowed, you would be able to connect from home or from your phone or whatever and test drive your little web app. And you can change that stuff on the fly. So if I wanted to, let's see, which one was it? It was this one. If I wanted to go in here and open this up so that you guys can get to it, I'd have to create a new security group or modify the existing one. So we'll do that real quick. So inbound rules, we're going to edit. We're going to add port 8080. And we're going to open it up to the world. Anybody in the world will be able to get to it. And so if we save that and I send you guys this link in the chat, if I can figure out how to get to the chat.
if you kind of hover your mouse at the bottom menu, the bottom window or tile bar or whatever will pop up once you start wiggling your mouse.
Well, I've got two
Gotcha.
monitors here, so that may be part of it. I don't know. It's not showing up.
Yeah, you got to be on the. You can't be on the application. You've got to actually be on the Zoom tab or window or whatever. And then anytime you move your mouse, you'll see the like the button where you could mute yourself, or turn off your camera.
Yeah.
The chat window's in that same. If you can find that find that window.
That's what this is, but it's not. Oh, right there. Sorry, it was bright orange. Okay, so I'm gonna send this to you guys, and with any luck, you can click that, and it should take you here.
Yep. How about that?
All right. So there's maybe two other things that I want to talk about real quick before we kind of do a Q&A if anyone's interested. So there's two other pieces of functionality that are tied into this EC2 service, which is their virtual machine service. So there's load balancing, and then there's auto scaling groups. So load balancing, you can create a load balancer and give it a static IP address. And if you have a domain name that you've purchased, you can associate this load balancer with that domain name. So you could hook this thing to arkansascodingacademy.com or whatever. And then you can configure routes so that if you wanted to go to Randall's application, for example, you'd put in a DNS entry and a route for your load balancer to say, if we go to arkansascodingacademy.com/Randall, it'll take you to his web server over here. You can also, that's not really what load balancers are intended for, but you can do them that way with a single instance. If he had 5 web servers that he wanted for redundancy, one that's in China, for example, and one that's on the East Coast and West Coast, and one that's in Europe, and one in Japan, you can configure load balancing so that the source of your web request, so say somebody in China hits your website, it routes them through Amazon's data center that's in China, so it's faster for them. Someone on the East Coast, same thing, that's geographical routing. You can do round robin routing, which just flip-flops between any number of geographical locations. You could do weighted routing so that X% of your traffic goes to one data center, Y% of traffic goes to a different data center. And I say data center, it's not really that simple. They have this concept of regions, which is like US East 1 and US East 2. And inside each region, they have availability zones, any number of them, 3 to 5 typically. And within each availability zone, they have any number of unknown data centers. So it's not like you're telling your web application which specific data center to run in. You just give it a region and an availability zone, and they handle the rest on the back end. So you're not really tied to any particular physical data center. It's a concept of availability zones, which may span, the Midwest may have, 5 availability zones, but there could be 50 data centers within those availability zones. So there's redundancy built in there. And another concept for web applications specifically is auto-scaling groups. So you can set up an auto-scaling group. You configure it to use you do your configuration ahead of time for your instance, like we did. That does all the deployment and everything built in. You create an auto-scaling group and tell it, I want to have at least 5 servers minimum for redundancy and performance. But if the demand is high enough, I want to scale those up to 50 web servers, for example. So if you get an influx of traffic, it'll automatically spin up new virtual machines, and your load balancer will automatically route additional traffic to those other virtual machines. And when traffic dies down, it'll kill those extra resources so you're not paying for them when you're not using them. So that is sort of quick and dirty virtual machine overview on AWS. Like I said, that's just one of the services that they offer out of, gosh, probably, I don't know, close to 100, more than 100 at this point. They also, if anyone's ever used or heard of Docker containers, that's super popular on AWS. So you package and compile your code, and instead of deploying an entire virtual machine, you basically just deploy a smaller packaged version of your code through Docker, and it deploys your web application shared on a different machine that you don't have any insight into, alongside any number of other customers. But the benefit of that is it's small and easy to deploy, and you don't have to manage the overhead of a VM, whereas with EC2 you do. So I'm going to stop there. Any questions around this specifically, or around AWS in general, around development professionally, anything like that?
I was going to ask, what would be your best advice on getting into learning Linux quick and just on the side being able to tinker with it while we're still learning all of this about Java?
So how far along are you guys into your course? Did you just start?
Next week will be week 5.
Yeah, this
Okay.
is week 4.
Okay, so you've got a decent understanding of development just in general, and I guess you're doing it all on your laptops, which are Windows, I guess.
Right.
Yeah. So Justin, the first 5 weeks is it is all focused on object-oriented programming, and it's just solving, thinking like a programmer, solving problems using Java. So they have not really moved into, RDBMS fundamentals or even HTML, CSS, JavaScript yet. But they understand they're coming to the end of the core OOP principles.
Gotcha. So the best way, and everybody learns differently, right? The best way for me to learn is hands-on experience. So what I would do is on the side, either buy a $5 a month virtual machine online, or sign up for AWS and spin one up for free for a year, or install it excuse me, as a dual boot on your machine and just play around with it. Get in there and do everything that you're doing for class through Eclipse or whatever IDE you're using. Try to do the same thing command line in Linux. And when you run into an issue, just Google it, and there's hundreds, thousands of folks out there that know what they're doing, and chances are the problem you're having has been solved any number of times before. So an IDE like Eclipse is nice for managing things for you, but it's also helpful to know how to compile Java command line, for example, and package it and deploy it, instead of just going through a GUI to click and do that for you. So I would install it separately and just try to replicate what you're doing out there. Just get used to it.
Right on.
Any other questions?
If you guys aren't there yet, didn't raise your hand or wave or something if somebody else had a question. I thought Charles might have something he might want you to explain, because like I said, the guys haven't really started working on their web server on their laptop yet. So this is a kind of a preview, but I'm sure once they get to the end, they'll think back to this, or they can rewatch this because we're recording it, and it'll start to set off some questions. Charles, did you have anything you wanted to add or comment on for this audience, and as well as the anybody that'll watch this after the fact on the recording?
I guess in general, I just want to say the EC2, the actual server that he's spinning up here, that is literally mirroring what our IDE is doing for us. Our IDE is pretending it's a Tomcat server, and it's going to load the application that we're building in Java that has these resources, including the website that he's showing us. And so ultimately, that application that we're running on this EC2 has the ability to connect to a database and pull information back and forth. So it's actually connecting to a database that's running. I guess you aren't doing the standard RD2 setup. You actually have an instance you created, but it's actually connecting to the database server. And so the big concept here is, instead of letting our Eclipse do it, on our personal servers, we're gonna at one point install Tomcat on our laptops. And then we're gonna watch our IDE Eclipse take that application. Instead of having to load it in the Eclipse, we're gonna be able to load it on our local Tomcat server. And ultimately, our goal is, the next step is we're going to be doing that same thing we're doing locally, installing it on a Tomcat server, but we're going to be doing that here where he's showing us in the cloud. And that's going to make it publicly accessed. So when he says we're going to manually learn how to, to learn to manually do what your Eclipse is doing for you, that's essentially the step-by-steps of what the Eclipse is doing for us and how we're going to migrate this out into the cloud, into the AWS.
Yeah. So just to touch on the database thing, I know you guys, I guess, have not gotten into SQL yet, but here is the SQL file that Randall provided me. So create the database and drop the tables if they're already there, create them again. And then if we go further down, it inserts, the records that make up what runs his web app. And so like Charles mentioned, yeah, the database is running on this same virtual machine, and the web application is talking to that database as if it was somewhere else. So this database doesn't necessarily have to live here. It could live on a separate virtual machine, or it could live on the serverless database that I talked about, where you don't actually have to log in here. By the same token, you can set up a database virtual machine and run it in AWS and still deploy your web application to your local machine and have it talk to the database in AWS. So there's really no limits on that. As long as it's publicly accessible, your resources can be anywhere on your local machine, on a virtual server in EC2 or Microsoft or Google, or anywhere, a physical server somewhere. And as long as the gates are open, the firewall rules are there, they can talk between one another without issue.
Yeah, and guys, you can create a lot of your database using a GUI tool. Um, so you don't have to use SQL as a data definition language to create tables and columns and rows and dependencies and insert your data and all that. But I encourage you to do that. It seems to be an SQL script using that language SQL and putting it out in almost like a program file or a script is the most portable way if you ever wanted to like recreate your database in another flavor of a database, rather than going through some kind of standard export and import and all that. Those scripts will allow you to spin it right back up, just like Justin did with Randall's project. So that's all I'm saying is that anything that you create, if you can script it, make sure that you have the code for it. You may wish you had that in the future.
Yeah, and when you get into working with different flavors of databases, there's going to be some differences between an Oracle database and MySQL or SQL Server. So it's best to pick one and just kind of stick with it. Under the hood, they all do pretty much the same thing. It's an RDBMS, right? You interact with it the same way, roughly. I would say, I know, Don, I think you mentioned that there's a few students that have used Microsoft SQL Server in the past as their flavor of choice. Just for ease of portability and everything that goes along with it, I would try to point folks towards MySQL or MariaDB, just because it's open source, it's free, and it's kind of ubiquitous out there for web applications. It's been around for a long time, and that's what most web applications, I would say, use outside of enterprise. Enterprise, they'll use something that's a little more robust.
Okay. Well, Justin, I sure appreciate you coming. I'm going to give everybody wave your hand really violently if you have a question. Otherwise, nope, no takers. Okay. Justin, thanks, man. Offline, or if you can do it while we're recording here, is there anything on here that's going to cause a security issue if I post this to our wider, graduate and current students, any of these IP addresses, or will you tear all this down and it's
Yeah, this is all going to get torn down. So
nothing on your screen, even your username or whatever, is going to cause any sort of a concern for you?
Nope, all good.
Okay,
Now,
great.
if they're watching it in the future and they try to hit that URL that I sent, it's not going to work because I'm going to tear it down and it's not going to be there.
Yeah.
But other than that, yeah.
So yeah, please do. By the time I'm hoping that you've annihilated all of this by the time I even have a chance to save this Zoom recording and upload it to YouTube. But sure appreciate it, Justin.
Yeah, no problem.
Guys, you can kind of see, Justin's a developer that moved into this world, but he's kind of got it all. Not just the problem solving aspect of and user interface of a website, but no kidding how these servers and protocols communicate with each other to truly make a usable application. So appreciate the guest lecture, Justin, and I'll be in touch. I'm gonna hit stop recording, and let you guys get on with lunch or.
Real quick, Justin, how long is this gonna be up? Just so we can. I just want to say, if I talk to them about this site this demo that's already been presented.
You're talking about the URL that I posted?
Yeah.
I could leave it up. How long do you need it up? I can leave it up for a little while. That's fine.
I mean, we'll be done with by lunchtime. I didn't know if you were gonna.
No, I can leave that one up for a few hours. That's fine.
Okay. All right, I'm gonna hit stop record. You guys keep talking.